Welcome to my Advent of Code Prep Series Part 2. If you don't know what Advent of Code is, it's a challenge that's held once a year, every year, starting December 1st, where every day a new programming challenge is released. Our goal is to solve it as fast as possible, as your score directly correlates to how many people you beat to solving the problem. I'm preparing for this year's Advent of Code by doing the previous year's challenges, and this is Part 2 of that series. So check out Part 1 if you'd like more information. Now let's get into the problem. The shopkeeper at the North Pole tow bag and rental shop is having a bad day. Something's wrong with our computers. We can't log in. You ask if you can take a look. Their password database seems to be a little corrupted. Some of the passwords wouldn't have been allowed by the official tow bag and corporate policy that was in effect when they were chosen. To try and debug the problem, they have created a list, your puzzle input, of passwords according to the corrupted database and the corporate policy when the password was set. For example, suppose you have the following list. And then there's a sample list. Each line gives the password policy and then the password. The password policy indicates the lowest and highest number of times a given letter must appear for the password to be valid. For example, 1 through 3, A, means that the password must contain an A at least one time and at most 3 times. In the above example, 2 passwords are valid. The middle password, this one, is not. It contains no instance of B, but needs at least 1. The first and third passwords are valid. They contain 1 A or 9 Cs, both within the limits of their respective policies. How many passwords are valid according to their policies? This is my input. Okay, so let's get into the problem. So this is valid because it needs 1 through 3. So A needs to be 1 to 3 A's in this given password, and there's 1 A. This one, there needs to be 1 through 3 B's in this password, and there's no B, so it's not valid. This one needs 2 through 9 C's given this password, and it's valid. Okay, let's get into the coding. The first thing I'm going to do is I'm going to get my input, and I'm going to paste it. I'm going to paste it into here. All right, so now that's saved. And the first thing I want to do is read each line of the input and store it into an array. So I'm going to do that right now. Here we have us reading our input file of the given input, and then we convert it to a string, and then we split the string into an array based on every new line. So as you can see here, so each array element is a line. Within each element, we have to split into its own array and parse it by space, so we can get this as one section, this as one section, and this as one section. And I'm going to do that right now. So now we have each line as an array of elements, which are split by the spaces of the line. So as you can see here, 1 through 13, and then J, and then the actual password itself. For every line now, we have to determine if the password is valid or not. What we have to do is split the first one by the first number and the second number, and then parse the middle element by the actual letter, and then check if that letter is contained within this. So something like, if this letter occurs within the range from this to this in this password, then it's valid, else it's not valid. I think we have to have a counter, but let's see how we're going to do this. Basically what a map is that it iterates over every element within the given array, and it spits out a new array. So as you can see here, it'll iterate over the entire parsed array, and it'll spit out a new array. So that's what it does. We are going through this array, which is an array of arrays, which contains each line. And what we're doing is we're setting a variable to false, and we're also setting a count to 0. We're iterating through the password right here. So it basically counts how many instances of this letter is within the password. And then we parse the range input right here. We split this between this number and this number. If the letter is within the range, so here's us parsing it right here. We split that string between this dash. We basically parse it to a number here, and we say that if the count is greater than or equal to the lower range, which would be 14 here, or less than or equal to the high range, we switch is valid to true and return it. And basically what this will do is return an array of booleans. It says right here. array of booleans of true and false, and we can just count how many trues and how many falses and then return it. So let's do that right now. So what this is doing is it's going through that arrays of true and falses and checking for if the element is true, then we increment a count, and let's display true count. So that will increment every time that the password is valid. So let's check 1000. Let's see if we're right. That is not the right answer. So let's see what's going on here. I found the bug in my code. I set this to an OR statement. So if the range is greater than or equal to the bottom end, or less than or equal to the top end, then change it to true. Guess what? That is literally every number, because every number is greater than or equal to the bottom end or less than or equal to the top end. So that statement resolves always to true. So we can change this to and that should fix the problem. 483 should be the solution for reals. That's such a dumb mistake, but I caught it because it was always evaluating to true. So I just changed it. So yeah, let's go. Boom. Let's fucking go. All right. So let's go to part 2. While it appears you validated the passwords correctly, they don't seem to be what the official Tobagan corporate authentication system is expecting. The shopkeeper realizes that he just accidentally explained the password policy rules from his old job at the sled rental place down the street. The official Tobagan, oh, it's Tobogan, not Tobagan, corporate policy actually works a little differently. Each policy actually describes 2 positions in the password, where 1 means the first character and 2 means the second character, and so on. Be careful. Tobogan corporation policies have no concept of index 0. Oh man. Exactly one of these positions must contain the given letter. Other occurrence of the letter are irrelevant for the purposes of policy enforcement. Given the same example list above, this is valid because position 1 contains an A and position 3 does not. This is invalid because neither position 1 nor position 3 contain a B. This is invalid. Both position 2 and position 9 contain a C. Now, how many passwords are valid according to the new interpretation of the policy? So exactly one of these positions must contain the given character. Okay, so we just have to change this a little bit. So what I'm thinking is that we can keep it up till, so we just have to change the logic within this part, because this is where we're processing each input. We'll parse it first, and then we check for each of the specific index if one or the other has the character. So let's do that right now. This returns the indexes. So it'll be like index 4 or 7. So we have to check it, but they don't have index 0. So this index will be a +1. So instead of being at 4 or 7, we have to check for index. We have to check for index 3, 0, 1, 2, 3, which is the fourth character or the third index. Equals true. Oh, but we need XOR. So what we do is that we split this part into 4 and 7, and then we subtract each one off the end. But then we have a logical XOR, which checks for one of these positions, not both. So if this or this is true, and this is not true, then we'll set is valid to true. So that's what basically a logical XOR is. If you're not familiar with logical XORs, it basically checks for only if and only if one of the statements is true. So yeah. So if we run this, 2, 2, 0. Okay. So now we have an issue. I don't know what is going on. That was really dumb. So right here I had -1 instead of +1. So this should work though. So 392. Damn it. All right. That's not right. Wait, I think it actually, I was right the first time. It should be -1, but I'm getting false everywhere. And it's not even printing my element. Oh, I know why. Wait, no. Parse-in? Oh, shit. I didn't have an equals. Okay, so the problem that I had is that I was not checking if the actual character at the element equaled the character that we're looking for. Okay, so just to reiterate our solution, for each element, we split that first element between the first index and the second index. So we split it between 1 and 3. Then what we do is that we check if the character at the first index or XOR the character at the second index is equal to the target character, then we switch it to true. And if not, we return false. So it's just using a logical XOR is really the trick to this problem, I think. So yeah, this should work. And I made that stupid mistake of not actually checking if it actually was the target character. Boom! We got it. Let's fucking go. Okay. That was way harder than it needed to be. Stupid mistakes meant that I was not checking for the right thing. So, yeah. I don't even know if that's going to make it into the video, but hopefully it does. Hopefully you enjoyed this. This was way longer than it needed to be. Thanks so much for watching. If you liked it, drop a comment or drop a like and join the Discord so that you can keep up to date with the things that I'm doing. All right. I'll see you in the next one.